All right, I may have tried this once yesterday. Gave up because it didn't save. Oh, awesome frustrations. I hope you guys are doing great. This is the last part of the review, focused on factoring and solving by factoring. So this has kind of been the new stuff you guys have done since we've been online. I hope that it's going great. I'm going to work through these again just really quickly. Hopefully you've already tried them on your own, and this is just kind of a way to check or get some help if you need it. So factor each of the following expressions completely. Just to remind you, when we're factoring, the step number one is to make sure it's just always in standard form, right? So put it in standard form if it's not. All of these are given to you in standard form, so I guess we don't need to list that as a step, but important to understand that we can factor it correctly. And then step number two, always look for that greatest common factor, right? Whatever it is, you're going to go ahead and pull that out front. And then if you can, you continue to factor. So if it's a trinomial or a difference of squares, then we continue to factor and break that down. This whole first page is just factoring, and then on the next page we would add a step 4 and we would say solve or state the solutions. So on this one, again, we're going to go through and we're going to factor. We look for a greatest common factor, right? That's what we're always asking. In this case, there's not one, so we go ahead and pull this apart. Remember, this one has a 6x squared at the front, so that could be 2x and 3x, or it could be 6x and 1x. And at the back here, we've got 1 and 1, so that's kind of nice. Just have ones. So we know that those are going to go into those parentheses. We just need to figure out how to pair them. We know that they're going to have the same sign, right? They're both going to be negative, so that makes that a little bit easier. So they need to have a sum, or they need to add to the -5. So we can kind of see that if we do 2 and 3 and match them each with a 1, that would give us the -5. Be very careful if you try and do the 1 and the 6, right? Those subtract and have a difference of 5, but we need the same signs on this one. So we're going to do 2x and 3x, and the lucky thing here is they're both 1 and 1, so those ones work out really nice. Number 23, again, we look for a greatest common factor. There's no greatest common factor that divides out of these ones, so we just go ahead and split it up. Now this one splits up nicely because it's just b squared, so we go b and b, and then we look for factors of -20, right? It's -20, so they're going to have a difference of -1. So it could be 2 and 10, right? But that has a difference of 8. Could be 4 and 5. That has a difference of 1, and we want it to be a -1, so we're going to do 4 minus 5 to get the -1, or in other words, a +4 and a -5. Awesome. 24, very similar. Notice everything's positive here, and there's no greatest common factor, so we go x and x. We need factors of 10 that add to 11, so that would be like 10 and 1, and again, everything is positive on this one. Number 25, again, we look for greatest common factor. This does look like it has one. It looks like we can divide a 2 out of everything, so we pull that out first. We get x squared minus 2x, and half of -160 would be -80. So when we go ahead and split that up, that worked out nice. We've just got an x squared that splits to x and x. We've got a -80, so these signs need to be different, and they need to have a difference of -2. So that would be like 8 and 10. And we want the -2, so -10, so we're going to have +8 and -10. Okay. Jumping down, if we look at the next one, we've got 3n squared minus 19n minus 40. Notice on this one, there is no greatest common factor. We'd like there to be, but nothing divides out there. So we are just going to go ahead and try and split that up. So when we break this apart, we've got 3n and n. That's the only thing that'll give us that, right? I'm going to write it up here. And then we've got a -40. So that could be like -4 and 10, or 10 and -4. Sometimes I just don't put the negative there yet, otherwise I have to list out so many of them. So it could be like 4 and 10, either one could be negative, or it could be 2 and 20, right, or 8 and 5. So those are all some possibilities, and then we just want to see if we can combine them. So like the n and the 8, that would be like 8n, and the 3 and the 5, that would be 15n. That has a difference of 3, so we know that it's not going to be that one. If I match the 3 with the 8 and the n with the 5, notice that gives me 5n and 24n. those ones have a difference of 19. If this 24 is negative, negative 24n plus 5n is negative 19. So I'm going to slide that negative back with that 8. And we know that we want the 3 to multiply by the negative 8, so we put it on the outside with the other. And we want the 5 right here. And then again, you can always check your answers. Again, we'll get 3n squared, perfect. We get negative 24 plus 5n, that gives us that negative 19. And then we get negative 40 when we multiply last times last. Moving to the next one, again, we look for a greatest common factor. There's not one on this, so we go ahead and list out some factors. This could be 3r times 3r or 9r times 1r. Those are our possibilities there. Then at the end, it looks like it could be 2 and 6, or 3 and 4, or 1 and 12. So if we look at this, we're looking for numbers that actually get pretty big, right? Because they need to add to 56. So I'm not going to start by multiplying like 3 times 3, that's 9, right? 3 times 4 is 12. Like, I can see that some of these aren't going to match as well, and I probably want to use this 9 so that I can get a big number. And so I can tell right now that I probably want to do 9 times 6. That gives me 54r. And then 1 times 2 is 2r, which adds to that 56. So if you know that you're dealing with a large number, you can use those larger factors. So we get 9r and 1r. We want the 9 to multiply by the 6, so it goes on the outside there. And everything is positive in this case. So we're looking at these factors. Number 28. Again, if we're walking through the steps, we look for a greatest common factor. Notice the greatest common factor in this one is an n. All we can do is pull out an n, and that leaves us with, when we divide that by n, we get n plus 7. That's all we can do. There's no other squareds left. There's no difference of squares, no trinomials. That's the end on that one. 29. Again, we look for a greatest common factor. In this case, it looks like it's 6, so we're going to pull a 6 out. That leaves us with 3v squared minus 7v plus 4. Again, we go ahead and pull this apart. So in this case, it looks like 3v and v are the only options there. Our signs tell us that they're both going to be negative, right? Because that's positive there. And then we just need factors that match to give us a 7. So it looks to me like if I try and use these factors right here, I'm going to get 6, but then I'm going to get 2. And 6 plus 2 is too big. It's not 7, so maybe 1 and 4. So if I do 3 times 1 and 1 times 4, that should work. So we're going to do 3 times 1, so I'm going to put those on the outside, and 4 times 1. And then again, you can always like FOIL to make sure that you factor correctly. And on the test where it's going to be multiple choice, most of it, you're going to be able to work backwards as well as forward. All right, last page. 30 again, same steps. Look for your greatest common factor. There's not one there. Notice there's no middle term either. This one's a difference of squares, so this is one of those that we pull apart. We know that it's going to be 3v and 3v, and it's going to be 4 and 4 because these have to be identical, and then they need different signs so that that middle term adds to 0. 31, we look for a greatest common factor. In this case, a 5 divides out of both pieces, so we get 4n squared minus 1. And then again, that's a difference of squares. So there's still a squared piece there. We can factor that down to 2n and 2n. And we can factor it down to 1 and 1. One of them positive and one of them negative. It doesn't matter which one you make which. All right, solving. So these are the same steps, but we're going to add the last one, right, stating the solution. So on number 32, again, it's equal to 0. That's perfect. So then we're going to go ahead and factor that. We go x and x. Factors of 12 that add to 7 would be 3 and 4, and everything is positive here. So when we state our solutions, we say what plus 3 would be 0, and that would be a negative 3. And here we could get a negative 4. 33, again, we're factoring here, so there's no greatest common factor. It's already equal to 0. So I'm going to split this up as 2r and r. It's a negative 21 at the end, so we know they're going to have different signs, and we want them to have a difference of 1. So we can see that right there, okay? So if I have 2r and r, and let's say 7 and 3, if I use 21 and 1, 21 is probably way too big to give us a difference of 1. So we're going to look at this, and we're going to do r and 7, and 2 and 3, so that gives me 6r and 7r. That has a difference of 1, right? We want 7r minus 6r, so we move the 3 to the back. So we do plus 7 here and minus 3 here. Okay, so when we state our solutions on this one, again, we're going to have r equals 3, and we're going to have r is equal to negative 7 over 2. 34 is already factored for you, so don't overthink this one. It's set equal to 0, so we just have to say x is equal to 8, and x is equal to 5/4. Again, remember when you're finding that one, if it's going to be a fraction, we're just saying what would make this equal 0. And if you add the 5 over and divide by 4, then you get that 5/4. It is important that you make sure it still equals 0. If it didn't, then you would need to FOIL this and then move whatever this is over here and refactor it. So make sure you're good there. 35, again, this one's just not equal to 0 yet, so we would do b squared plus 5b, and we have minus 16 equals 8. You just need to move that 8 over to start with. So we would have b squared plus 5b minus 24 equals 0. As we factor that, we get a positive 8 and a negative 3. Notice that would give us the 5b in the middle and a negative 24 at the end. So b is equal to negative 8 and positive 3. Again, you can also solve these by graphing. So remember, you could graph this and see where it crosses the x-axis. Okay, number 36. Again, these ones have some terms on the other side that we need to move. So let's add the 12b over here. I like my b squared to say positive, so I'm going to move everything over towards the b squared. So b squared plus 12b. It looks like I have a 2 there as well. Let's move the 2 at the same time. So we're going to have plus 36, and then we left nothing on the right-hand side. We go ahead and factor that. Everything is positive on this. So we have b plus, b plus. Factors of 36 that add to 12 would be like 6 and 6. So in this case, we get b is equal to negative 6. You can write that twice if you'd like to, or once. Doesn't matter. They're the same solution on that one. So that's perfect. Okay, 37. We're factoring out a 5 on this one. It looks like it's already equal to 0, so we just need a greatest common factor there. If we divide out a 5, we get x squared plus 8x plus 15 equal to 0. And 15, the factors would be 5 and 3. So we would get x equals negative 5 and x equals negative 3. Answer would be D. Okay, I feel like I forgot to do our last joke, so we better do that one really quick. This says, how can you tell that the fractions, I gotta draw a picture for this one, x over c, y over c, and z over c are visiting a foreign country? The answer, because they are all overseas. Yep, it's a good one. Okay, for each of the following linear equations, write the equation in slope-intercept form, solve for y, then state the slope and the y-intercept. So this one's just practicing back to our linear. If we want to put it in slope-intercept form, that's y equals mx plus b, so we need to solve for y. So let's move everything away from the y value. So we get 5y is equal to negative 4x minus 15. We divide everything by the 5. Y is equal to negative 4/5 x minus 3. So for part A, we wrote the equation in slope-intercept form. Part B says state the slope, so just make sure that we're good at identifying that slope there. And then part C, state the y-intercept, which would be at 0, negative 3. Again, if it's ever in standard form, remember to find that slope, you've got to put it into the slope-intercept form. And then our last one, 39, same idea. So you're going to move that 7x over to the other side. Negative 5y equals negative 7x minus 10. Divide by negative 5, divide by negative 5. Y is equal to positive 7/5 because a negative times or divided by a negative. And negative 10 divided by negative 5 is positive 2. So over here for our answers, we've got 7/5 x plus 2, part B, 7/5, and part C, our y-intercept there would be then the positive 2. All right, you guys are awesome. Best of luck on this exam. Just make sure you read through each question thoroughly. And then if you need to work backwards on some of those short answer ones, or multiple choice, you should be able to do that.